section is on alternate interior, alternate exterior, and corresponding angles. And all three of those angles are solved in the same exact manner. So the expressions are going to get set equal to each other. So it's still important that you understand what angles are alternate interior angles. So again, that is angle 3 and angle 5. So again, remember they have to alternate the sides of the transversal, which is this line right here. They also have to alternate the parallel line that they touch. So 3 touches the top parallel line, 5 touches the bottom parallel line, okay? And they have to be inside the line, okay? So right here on the inside. We also have another pair of alternate interior angles, and that's 2 and 8. Now you might notice I single marked the 3 and the 5, and that's because those are equal to each other. And I double marked the 2 and the 8. Those are equal to each other, but they're not necessarily equal to 3 and 5. They're only equal if these lines are perpendicular to each other. Well, we also have alternate exterior angles, which do the same thing as alternate interior angles. They alternate sides of the transversal. They alternate the parallel line that they touch. The only difference is they're on the outside of these parallel lines. So again, you might have noticed I single marked that, and that's because 1 and 3 have the same measurement, so do 5 and 7. And I'm going to double mark the 6 and the 4. So 1 and 7 are alternate exterior angles, and so are 4 and 6. And then we have a whole bunch of corresponding angles. So if we think of this as the top side, the right side, the bottom side, and the left side. Over here in the other X, we also have a top side, a right side, a bottom side, and a left side. Okay, so 4 and 8 are both the left side, so they're corresponding angles. 3 and 7 are both the bottom, so they're corresponding angles. 2 and 6 are both the right sides, and 1 and 5 are both the top sides. So if you have any of these angles, you are always going to solve them by setting them equal to each other. So you'd set 1 equal to 7, you'd set 4 equal to 6, etc., all the way up and down this list. All right. So I'm going to want you to be able to identify the relationships. Okay, so we're talking about 1 and 7. Okay, so again, notice they're on the outside of these parallel lines, and they've switched both the parallel line that they touched and they've crossed the transversal. So this is an alternate, which I'm going to abbreviate as ALT, exterior angle, which I'm going to abbreviate as EXT. Okay, if I want to solve these, what I'm going to do is I'm going to set those two expressions equal to each other. So 6x plus 20 is going to be equal to 8x minus 8. And from there I'd solve. So I always like to take care of the smaller x, because 6 is smaller than 8. So I'm going to get rid of 6x on the left-hand side. Well, if I'm getting rid of the x's over here, that means I have to get rid of the numbers over here. If I want to get rid of a negative 8, I need a positive 8. And now when I add these two together, the left side gives me 28, and the right side gives me 2x. So hopefully everyone knows the next step would be to divide out 28 by 2, and that would give me an x value of 14. All right, so it's asking for angle 1, so remember we can travel back to this angle. We have 6 times 14 plus 20. And if you need to, you're welcome to grab your calculator. 6 times 14 plus 20 gets me 104. Now, if you like to check your answers, if you plug 14 into this expression, it should also give you 104. So we'll just double check this really quick. 8 times 14 minus 8 equals 104. All right, now be careful of what angle they're actually asking for. So it's asking for angle 1. But it's not asking for angle 7, which I just solved for. It's asking for angle 4. Okay, so you have to understand that this right here created a linear pair. Okay, so if I wanted to know what angle 4 equals, I would simply just take 180. I would subtract the 104 from angle 1, and I would see that this angle is 76 degrees. Okay. And these diagrams are never drawn to scale, so please do not pull out a protractor and measure them. All right. for the next example, so here we have this arrow pointing at 2, and then this right over here is at 6. Well, notice those are both the right-hand sides. So these are our corresponding angles. Well, our corresponding angles, again, are solved just like the previous example. They're set equal to each other. Okay, and that's because they have the same value. So again, if I trace this angle, I could drag it up and it'd be the same exact angle as angle 2. So again, when I do this, I always like to keep my x's positive. So since this 1x is smaller than the 5x, I'm going to get rid of the 1x. Well, if my x's are going away on the left, that means my numbers have to go away on the right. So this adds up to 40 on the right side and 4x on the left side. And again, hopefully everyone knows we're going to take the 4 out of that by division. 40 divided by 4 tells me that x is 10. All right, if we wanted to figure out what our angles measure, we'd plug 10 in there. 10 plus 35 is 45. And we put a 10 there. 50 minus 5 is 45. Okay, so that's a way you can check to make sure that you have the right x value. So again, we know that angle 2 is 45 because we just calculated that. Well, again, if we want to know what angle 1 is, notice angle 1 creates the straight line or the linear pair with angle 2. So I would take 180, I would subtract 45, and that would tell me that angle 1 is 135 degrees. So you have to know angle 2 in order to be able to get angle 1. And if angle 2 is wrong, angle 1 is probably going to be wrong as well, which is why I think it's important to check that our x value makes sense in context of our problem. All right, one last example for this section, and that is this relation. So again, the arrow points to 3 and 5. So these are alternating sides of the transversal, which again, I'm going to abbreviate the same way, ALT. And they're on the inside, which I'm going to abbreviate to INT. And again, these are solved the same way that we've been solving all of these angle relationships in this section. Okay, they are equal to each other. So again, I'm going to take 25x plus 65. I'm going to set that equal to 50x plus 15. All right, so again, I like to keep my x's positive, so I'm going to get rid of the 25x on this side, which means I'm going to take care of the 15 on that side. Okay, 65 minus 15 is 50. 50 minus 25 is 25x. And again, hopefully everyone knows to get x by itself, we're going to divide out that 25, which is going to tell me that my x value is 2. So again, I like to plug the 2 in to figure out both of my angles. That's 100 plus 15, that's 115. That's 50 plus 65, that's 115. So again, even though it's not asking for both angle 3 and angle 5, it's only asking for angle 5, which is 115. I plug it into both just to make sure I didn't make any kind of technical error when solving for my x value. Now again, the other thing it's asking for is angle 6. So angle 6 is right here. So again, it creates the straight line with angle 5. So if we want to know what angle 6 equals, we would do 180, subtract 115, I borrow 65. Okay, so again, you have to know what the angle relationship is, how to solve for x. You guys now know how you can verify that your answer makes sense, and then be sure that you're paying attention to what specific angles it's actually asking for.